Hello everyone, I'm going to be going over the beginnings, which is section 1.7 of transformations in a plane. So transformations are maps of an initial image, and then we call the pre-image, and then a final image or post-image. So first one is a translation, it slides, reflection, a flip. There are three different types of flipping we're going to do. Rotations, which is also three different types of flipping. And then dilation, which is when you make things smaller, just like your eyeball. But just to go over these briefly to start, reflections, you're either going to reflect over the x-axis, the y-axis, or y equals x. Those are the three different types. And this one looks like it's a y flip. Also, when you do a pre to post image, they usually don't give you new letters. It's usually like A becomes A1, C becomes C1, and B becomes B1. But for these, they haven't done that yet. Next is translations. Translations is a slide. Usually they have directions, so like the x-coordinate moves over 3, and then the y-coordinate moves down. So here's the pre-image in blue and the post-image in red. Rotations. Rotations, these are the most common rotations, and they have formulas. We're not going to go over the formulas today, but here are the three types of turns or rotations. These are clockwise. Sometimes they are counterclockwise. They will be specifically noted. 1 is 90 degrees, 2 is 180, and 3 is 270. After that, we did take a little bit of time. I want to go over some of these examples. We have a rotation, we have a reflection here, and we have a translation here. I also went through the next section of 3.5, which is symmetry. It's important to know your symmetry. Symmetry has all these different terms. All right, so here are the different terms for symmetry. Symmetry is something you can map on itself. A line of symmetry, think of your face, your left eye, when it fits right on top of your right eye, the center line of your face, it's an imaginary line. That's the line of symmetry. Rotational symmetry is when you can turn something on top of itself, and I use this as an example. So like for instance, this one's rotational symmetry would be, it rotates, but it does, yes, have rotational symmetry at 360. And then the center is the middle when you're rotating. Order is the number of times it rotates on itself. For instance, a square can rotate on itself 3 times. So if you have a triangle can rotate on itself 3 times. So here's a triangle and it rotates. Here's rotational symmetry 1. If this was an equilateral triangle, 2 and 3. So that would be the order is 3. The magnitude, and that's the numbers here. So magnitude is the smallest rotational symmetry you can get when you're getting your order. So when it turns, it stopped at 120. It's the same where it started. 240, it's the same where it started. And 360. So the order is 3, and the magnitude is 120.